Ladies and gentlemen, now welcome to this channel, Just the Fake Amounts, and today we shall be treating atom, atom elements, and compounds. Atom elements and compounds. So first of all, let's start with atom. Then we'll move to elements, then we'll move to compounds. So what is an atom? Now, an atom can be defined as the smallest particle of an element. So, atom can be defined as the smallest particle of an element. That takes part in a chemical reaction. An atom is the smallest particle of an element that takes part in a chemical reaction. And there is something we call the structure of an atom. So, and the structure of an atom is where we have this. So now, here I have my electron, I have my shell or orbit or energy level, whichever we want to call it. Here I have my neutron, here I have my proton. Then these two together are called the nucleus because they are found in the nucleus of the cell. So this one, the overall, is the nucleus. So this is referred to as the structure of an atom. Atomic structure. So John Dalton, in his research, he said an atom can be defined as the indivisible particle. Indivisible particles. But later on in history, that later came back and checked and said, this thing can be divided. That's after the invention of an instrument known as mass spectrometer. So he did this further research and found that an atom can be split into three things. That is, it's made up of three subparticles, which are the proton, the neutron, and the electron. Now these are the three subparticles that makes up an atom. So he now the proton, he discovered that being the proton is positively charged, the neutron has no charge, while the electron is negatively charged. So now in this case, an atom is truly defined. It now redefined to be the smallest particle. It is divisible. It is small. It is the smallest, though still divisible. That is, you can still get some particles in it. Even from the proton and neutron, there is also made of some things that are quarks. Yeah. So now the smallest particles of an element that takes part in a chemical reaction. Now an atom takes part in a chemical reaction. The smallest thing that takes part in a chemical reaction. But I'm gonna ask you a question after we discuss this. Now the question is this: what if you are given an option A to D, option B, C, and D? So the first one, atom; second one, electron; third one, proton; fourth one, neutron. And the question is now, which of the following takes part in a chemical reaction? Which of the following takes part in a chemical reaction? What do you think the answer would be? Will it be atom? Will it be electron? Will it be proton or neutron? Because now the atom is the first particle of an element that takes part in a chemical reaction. So according to my question, that which of these following options takes part in a chemical reaction? Does atom justify the answer? Like, does it justify the answer of the question? I would say no. And the reason is what I'll be doing next. Now, I would just like you to stay with me to discover the reason atom is wrong in this case, though it takes part in a chemical reaction. Now let's take two elements for instance. Let's take hydrogen, and chlorine for instance. Now hydrogen being H, chlorine being Cl, right? So hydrogen has just one electron in it, and I'm talking about one. Chlorine has 17. So we have 1, 2, then next 3, 4, 5, 6, 7, 8, 9, 10, then next 11, 12, 13, 14, 15, 16, 17. Now looking at this thing, this is hydrogen and this is chlorine. Now this has just one electron in the atom's shell. This has 7 electrons in the atom's shell. The atom's shell is the shell, immediate shell you meet outside. That's the last shell outside. So it's the atom's shell. So I have 7 atom's shell, but total electron in this atom is what? 17. I hope you're following me. So now these two elements are unstable. And for them to be stable, they have to assume the group 0 or the group 8 element. They have to assume their position. And what's the assumption? The assumption is that either it is in duplet structure or the octet structure. Now the duplet structure is a structure whereby 2 electrons in the atom's shell makes the element stable. While the octet structure is a situation whereby 8 electrons in the atom's shell make the element stable. I hope you get what I'm trying to say. Now for hydrogen, it must assume the duplet structure. Why is it duplet structure? Because of what? It can only have one mole, as the first orbit of an atom is only entitled to what? To 2 electrons. So now for this thing to be stable, it has to be what? It has to add an electron here. Then we can say it is stable. For chlorine to be stable, it has to add 1 electron here for we to say that what? This thing is stable. So what can they do? They both need one, this needs one. So they can think of making an agreement with it then. And that agreement brings about a kind of bonding relationship referred to as what? Covalent bonding. Referred to as what? Covalent bonding. So when this comes close to this, what happens? They form something like this, okay? Just pardon, the first shell has 2 electrons, next one has it. I'll draw the last one completely. So I have 1, 2, 3, 4, 5, 6, 7, right? So now hydrogen needs 1, chlorine needs 1. Now okay, since you have 1, give me that one and we'll share my own too. So in that case, hydrogen has 1 originally. Okay, let me do it to differentiate them properly. No, let's do it like this. So here I have this. So hydrogen has this one, chlorine has this one. Okay, how about us sharing it? So your 2 will be complete, you'll be stable, and my 8 will also be complete in the atmosphere. Ours will be stable. It's actually a negotiation that happened between them, and they both agreed and they came together to become what? HCl. Now I want you to notice something there. And what's the one you notice? Now check it. What is the major thing coming in as the medium for transaction? What's the major thing that enables the chemical reaction to take place? Is it the whole atom? Is it the proton? Is it the neutron? Is it the electron? What do you think? Huh? The answer is the neutron. Why is it neutron? Because neutron is the major thing that is being used to help each other. For instance, my company needs, let me say, needs to hire a coastal bus for a particular journey, let me say excursion. Then your company needs money for its development. What do we do? And your company has coastal bus and mine doesn't have, but I have the money to sponsor the project you want to do. So what do we do? Okay, you give me coastal bus and I'll give you the money. It's one like renting or hiring a car or a vehicle. So in that case, what happens? A transaction. But what really occurred is not the whole me, it's not my company and it's the whole company that came into play. No, it's just what he has and what I have. And what does this thing have? It has 1 electron. What does this one have? It also has 1, in which this one is. and they came together. So the major thing that is allowing the chemical reaction to happen here is just the electron. So in any option whereby you find atom and electron being together, electron is the most correct answer. But for instance, assuming I have the question, the options to be like this, let me just put compound here. Compound. In this case, atom is correct. However, I'm saying is clear. So, but when both options, that's atom and electrons, are occurring in it, what happens? Electron is the most correct answer because it's the major thing that is coming into play for the chemical reaction. So that's that about that. So an atom is actually smallest particle of elements. And when this came out, actually, it was when John Dalton did his research, and there was nothing like subparticles, which are the electron, neutron, and proton. So the major part of an atom that is in the chemical reaction is what? Is the electron. Is the what? Is the electron. So that's that about that. So now let's move on to elements. Now, what is an element? What is an element? So now, an element can be defined as a substance that can neither be broken down or splitted into simpler or smaller units by any by any physical or chemical means. Now, an element can be defined as a substance that can neither be broken down or splitted into simpler or smaller units by any physical or chemical means. By any physical means or chemical means. That is, an element is just the way they are. They cannot be broken down into smaller pieces. No. The worst thing can do to an element is bombard it with another element. But breaking it down, that's impossible. So none of these means can break it down, be it physical, be it chemical means. None of them can break it down into any simpler units. So examples of elements is our hydrogen, for instance, chlorine, for instance, we have the fluorine, for instance. All these are elements: boron, carbon, calcium. All these ones are magnesium, manganese, like that. They are what? They are elements, examples of elements. I guess it. So that's that about elements. And compounds can be defined as a substance that comprises two or more molecules. And we can also define an element to be a substance that comprises two or more atoms, or that is made up of two or more atoms. So elements are made up of atoms. So, but atom may be referred to as, let me say, the building block of an element. So now, for the compound can be defined. Now, a compound can be defined as a substance that is made of two or more elements which cannot be easily separated. By physical or chemical means. So that's a compound. So in the first place, I said hydrogen coming together with chlorine, they became hydrogen chloride, right? Now that hydrogen chloride is a compound, but hydrogen separately, chlorine separately is an element. While the structure I drew is just the atomic structure of hydrogen, and the other one is the atomic structure of what? Of chlorine. So I hope all this is clear. So do meet us on the same channel for physics, mathematics, chemistry, and we will be there for you. So thanks for watching. Don't forget to subscribe, like this channel, also share with friends, comment below with your opinions, and we will be there to attend to them. So thank you very much. My name remains Angela Peter. Thank you very much. Meet you on our next class.